All right, so let's have a look at the normal curve. And in the previous video, I mentioned that in this video, I'd like to delve into the standard deviation and how the percentages work as you move away from the mean. Now, the standard normal distribution, okay, is called the standard normal distribution because the mean is always zero, okay, and if you move away from the mean, you can move one standard deviation away from the mean, two standard deviations away from the mean, three standard deviations away from the mean. Now remember, standard deviation, what does deviate mean? Deviate means to move away from. And a standard deviation is a number that represents how far on average every value, if I could say that safely, is from the mean. Let's say a quick example, I got 4, 5, and 6. Okay, if I add it up, okay, 4 plus 5 is 9, 9 plus 6 is 15. And if I divide it by 3, I know that my mean will be 5, okay? And my standard deviation is calculated by taking, firstly, the distance of each of these values from the mean. If I put 5 over here, and I say 4 minus 5 is negative 1, 0, and 1. That's the distance from the mean. And I square it afterwards, okay? It will come to 1, 0, 1, and then I add this up, it comes to 2. And I divide it by the total number of, so this is the sum of x minus x bar, and I divide it by the total number of values, which I have is 3. Then we're looking at 2 over 3, which is going to be 0.67. That would be my variance, in which case I still have to square root it, because remember I squared it here, so I do the opposite, square root it, and I get, so in a nutshell, this is what we can explain in another lesson, but for now, the standard deviation, you can see I'm minusing it from the mean, and I'm getting the distance from the mean. And I'm now trying to get it into a single value, which if I put it into a calculator, the square root of 0.67, just to give you a very rough idea of it, will be 0.8, 0.8. So in other words, if I add 0.8 onto this side, and if I minus 0.8 onto this side, I'll get close to the average. So it's the fairest value that shows me how far I am from the mean. Okay, but it's just a rough idea with some random formulas as well for that. Let me remove this here. We do that with more accuracy. Okay, going back here now. Think of it like a weather forecast. Imagine you're trying to predict the weather for next week. You don't know exactly what will happen, but you have a really good idea, all right, a general idea based on the patterns. So the bell curve's predictability works in the same way. I can't tell you the exact future, but I can give you an incredibly reliable odds that something might happen. So the simple rule is the mostly pretty much in almost everyone rule is that, let's go back to the example of having heights of 1,000 adults in a big room. And we said that the average came to 1.65. So because their heights follow the bell curve, all right, remember we had heights over here in the previous video. Okay, and that was actually, yeah, it was heights over there, and it was total number of adults, okay, versus heights in meters, okay. Now, because the heights follow the bell curve, you can be very confident about these three statements, okay. Mostly 68% if you bet that the next random adult you meet will be within normal range of heights. Not super short, not super tall. You'll be right most of the time, right? Exactly in that region. In fact, you'll be right about 68 times out of 100. That would be 68% in the central region. Now, what am I getting at? Where did I get the 68% from, and what does it mean? Based on the standard normal distribution, which I drew over here, the 68% is a always given value, standard value of the area between one standard deviation from the mean. The mean is 0, remember, right? So that area over there is 68% always. From there to there. And then about 95% of the data falls within 2 standard deviations of the mean. If I travel from here all the way across to there, okay, bringing in the -2 and the +2, I got 95% of the data falls within 2 standard deviations of the average. And then 99.7% of the data falls within 3 standard deviations of the mean. And you see we're getting closer and closer to 100%, which is actually the area underneath the curve. Oh, I just wrote 100%. 99.7%, not 100%. Within 3 standard deviations. Remember, 1 standard deviation in that particular example was 0.8 from my average of 5. So this would be 5.8. And then you keep adding 0.8 to get 1, 2, 3 standard deviations away from the mean, so that you can get the spread of data. Okay. All right. Anyway, 99% falls within the 3 standard deviations of the mean. Okay. And that example is aligned to the idea of the heights example, where we had 1.65 and we didn't calculate the standard deviation. We didn't have one, but let's say the standard deviation was 0.1. Then 1 standard deviation will be 1.75, 2 standard deviations 1.85, and then 1.95. And then likewise, you can see we're jumping up by 0.1, which is my standard deviation SD, and this is my mean, which is 1.65. These are the actual values, and this over here is my standard deviation, my standard normal distribution graph, which has zeros and ones. 0, 1, 2, 3, -1, -2, -3. All right. So going from one end to the other, I know. Let's have a look at the next part, which is the idea that the normal distribution is very magical. Okay, the magic is that this same simple rule works for anything that has a bell-shaped curve. The idea of being 68% majority. So if you gather data from a class, 68% of the class will be within 1 standard deviation of the average of the class. Okay, so let's say the average of the class for the next maths test, which was out of 100, the average came to 60%. And there were 20 students who wrote the test. If I multiply this by 68%, I will be able to get the total number of students that were within 1 standard deviation of that on average. Let's say if I had data outside of 2020 is a number I can actually calculate, a big number, let's say 20 million. So it goes really big. So this is going to be 13.6. So I can say there's between 13 and 14 students in this region here. So I can let's say produce a dot for each student. I would put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, let's say 14. And then 15, 16, 17, 18, 19, and then 20. And you can see the further and further you go away from the center, less and less the total number of students get those results as well. All right, the next video, I'm going to be looking at the standard normal distribution and why do we even have these zeros and ones. Okay.